Hello everyone, and then welcome to another tutorial video. So in this video we'll be just treating what differentiation tricks. Okay, after that we'll be treating what integration tricks in the next video, right? So in case you are new to this channel and then you are interested in finding the most smartest way to finding what the solution to problems, okay, maybe algebra, okay, something relating to algebra, calculus, integration and all that, make sure to subscribe to this channel, okay, and then turn on your post notification because we always upload useful and helpful videos on this channel, right? So without further matter ado, let's dive right into this video. So from this we'll be starting from what differentiation, okay? So differential equation. So the first trick will be most definitely, okay, so we know that the reciprocal, we try to reciprocate the expression. We have the general formula as what maybe d dx, and then we have maybe a function of f of what x, okay, right? And then you have to take the reciprocal. So that's why you try to differentiate, okay? So in this video I'll be just sharing with you how to easily arrive at what your specific answer, okay? This will be the simplest approach you ever find on every channel treating differential equations, okay? So let's say you have an example, okay? Let's say you are told to find d dx of maybe 1 x exponent 2, okay? So how do you do this? You might go by trying to take the reciprocal and all that, but I might tell you that the answer is minus 2 on x exponent 3, okay? So let's say another example. So we have maybe d dx, okay, and then we have maybe 1 on x exponent 5, okay? This is 5, okay, right? So I might also say that the answer correlating to this question, to this reciprocal question, is minus 5 on x exponent 6. So by now, if in case you are smart enough, you might have figured the answer, but in case you haven't, let me show you how you do this. So for the reciprocal rule, keep this formula in mind, okay? This is the formula you'll be using whenever you come across any question which you are to reciprocate, and then that's when you are differentiating, okay? That's when you are differentiating. So this is the formula you keep in mind, okay? This is the main formula you keep in mind, okay? Right, so from here you can notice that when you use or when you input these, you notice that you arrive at these answers, okay? So let me do another example so that you get to understand. So the x, okay, and then we have maybe minus 10 divided by x exponent 3, okay? So let's try to solve this problem. So as the formula implies, we have a negative sign, and then we have n. So n is 3 over here, but you already have minus 10 over here, so we keep the minus 10 over here. You multiply that by the 3. After that, you divide that by x. You have n plus 1. N plus 1 is 4, okay? So this will give us positive 10x exponent 4, okay? So this is how you go by solving differentiation when it comes to the reciprocal rule, okay? So let's move on to the quotient rule. Okay, so for the quotient rule, you know that is something like a fraction form of differentiation, okay? So let me just write the general formula. So we have the quotient rule, okay? It could be something like say we have maybe a function of f of x and y, okay? So we have f of x and y, okay, and then we divide that by another function of maybe f of only x or f of x and y, okay? It depends on how the formula, or in simply put, let's say we have another, okay, a quotient formula. In this formula, let's say we have f of maybe x, okay, and then we have divided by f of another x, okay? It depends on how the formula or the question will come, okay? So now let me show you how you smartly or solve this kind of quotient rule. Okay, so when it comes to the quotient rule, okay, so this is how the quotient rule looks like. So in case you want to see an example for quotient rule, I've just written one right here. So we have something like 2x plus divided by x minus 5, okay? So this is how a quotient rule looks like. So for a quotient rule, don't worry about these formulas, okay? The most important formula you need to keep in mind is this one, okay? This is the formula you need to keep in mind. It's very, very simple. So once you solve an example, you get to understand, okay? So for the quotient rule, whenever you come across the quotient rule, and then it's written in this format, okay? Maybe 2x plus 3 divided by what? X minus 5, okay? This is the formula you'll be using to solve the problem. Now, you need to keep this first formula in mind, okay? This means that f of x has to be below f of x, okay? This is what I mean. So from here, you can notice that we have what? 2x plus 3, and then we have what? X minus 5. So you can notice that we have x under x. But in case we had what? The formula to what? 2x plus 3 over what? Maybe 5 minus x. We would have rewritten this, okay? We would have rewritten this as what? 2x, okay, plus 3 divided by what? Minus x plus 5, okay? So in case it was written in this format, okay, that's why I stated that the x must be beneath the x, okay? They must be beneath the x. Now, once that is settled, now let's see how we solve this problem. So we know A. We know A is what? 2 over here, and then we have the f of x, which is this SK, and then we have B, which is 3, we have C, which is 1 over here, f of s is this expression, and then D is what? 5. Now, listen attentively, okay? Pay close attention. So, first you need to what? Differentiate f of x, okay? And then you multiply that by what? A times D minus B minus times C, okay? And then you divide that by what? C multiplying f of x plus what? D all squared. So, let me show you how we solve this problem. So we have what? F prime of x. So from here you can notice that I stated that both f of x must match, okay? They both must match. That's what I initially explained over here, okay? They have to match, hence we would have what? F prime of x. So let's see how we solve this problem. So from here we have what? A, okay? A, f of x plus b, and then we have c, f of x plus d. And then from here, you know that f prime of x is what? 1, okay? F prime of x. So when we differentiate x, we end up at what? 1, okay? Now we have what? A. So a is what? 2, okay? A is 2 multiplying what? D. D is what? Minus 5, okay? Minus 5. And then you subtract that from what? B. B is what? 3, okay? B is 3, and then you multiply that by what? C. C is what? 1 over here, okay? 1 over here. Now we divide that by what? C, which is what? We have C, which is 1 over here. So we have 1 also in brackets, and then we have what? F of x. So f of x is what? You know that our f of x, as I stated earlier, our f of x is what? X, okay? So when you differentiate f of x, you end up with what? 1, okay? So f of x is what? X, okay? Then we have what? Plus d. So d is what? Minus 5, okay? So we have minus 5, and then you square this. So from here we have what? 1 multiplying this, we have what? This minus 10 minus 3, okay, divided by what? This will give us what? X, and this will give us what? Minus 5 all squared. So from here you can just simplify this and get what? Minus 13 or what? X minus 5 all squared, okay? Note that f of x was what? X, okay? F of x was what? X. That's from this formula, okay? So we have a f of x. So this is a f of x, okay? F of x is what? X plus b, and then you have c, which was 1, and then f of x is what? X plus d, which was what? 5, okay? Then we go to understand that once you do that, you end up with this what? Solution, okay? So now let's move on to what? Square root function. So this is how what square root functions looks like. So we have d on dx, and then we have what? Root of x, okay? So once you want to solve this, the answer will be what? 1 over what? 2 root. So in order to arrive at answer, this is how the general formula looks like. So we have 1 over what? 2, okay? And then we have root of the differential of what? N, okay? This is how the formula looks like. So keep this formula in mind, okay? This is the general formula for square roots, okay? So let's take another example. So let's say you have what? D, okay, dx, okay? And then we have maybe square root of maybe x. So this is how the formula answer will look like. So first you need to write 1 over, and then you keep your roots, and then you write your n. N is s squared, okay, and then you multiply that by the differential of n. So the differential of n is 2x, okay. So you could just simplify this as 2x, okay, over 2 root x. Let's take a simple example. So let's say we have d1 dx, okay, and then we have maybe root of x exponent 4 plus 2, okay. So now this is how we solve this. The same principle, okay. 1 over 2 root of n multiplied by f prime of n. So we have 1 over 2 the root of n, which is x exponent 4 plus 2, and then you multiply that by the n. N is s exponent 4 plus 2, okay, just like here where n was x exponent 2, okay. So s exponent 4 plus s exponent 4 plus 2. So when you differentiate s exponent 4 plus 2, you end up with 4s cube, okay, because when you differentiate 2, you end up with 0. So you could just simplify this as 4s cube divided by 2 root x exponent 4 plus 2. This could be your final answer, okay. You see how simple this is. Very, very simple, very, very straightforward. Now let's look at the next concept, okay. Let's look at the next concept. As I stated earlier, this will be just combination of secret tricks as to how to solve differentiation, okay. Okay, so let's see. So this is implicit differentiation, okay. Okay, so for implicit differentiation, we know that this is the format, okay. We have maybe a function of x and y. So from here, this is d of dx, and then we have function of x and y, okay. So this is where we implement something like partial derivatives, okay. You differentiate x, you keep y, then you differentiate y, you keep x, okay. So this is the general formula. We have once you come across any form of this implicit form of differentiation, this is the formula you implement, okay. So we have minus f of, divide that by f of y. So let's take an example so that you get to understand, okay. So let's say we have let's say we have s squared y plus maybe e exponent x. For implicit differentiation, you have to equate everything to 0, okay. So now you just introduce your formula. So you know that we have minus f of x divided by f of y, okay. So this is what you need to do. So you differentiate this expression respect only x, okay. So we have 2xy, then we have plus e exponent x, okay. We have cos y, okay, and then you divide that by now we are differentiating respect only y, okay. So from here we have when you differentiate y over here, you end up at 1. So we have x squared, okay. That's why initially I stated that you differentiate y keep x constant, and then you differentiate x, you keep y constant, okay. So we have this is plus. Now you are differentiating this, okay. When you differentiate cos of y, you end up at minus sine, okay. You have minus sine of y, okay. Right, so you can just further simplify this as 2xy plus e exponent x cos of y, and then you divide that by x sine of y, okay. You see how simple this was. You could solve another problem, okay. Okay, so let's take this example, okay. So let's use the implicit rule again. So we have as I stated earlier, keep everything to 0, okay. So we have minus sy. Now you solve this fy, okay. So we have minus we are differentiating respect only x, okay. So we have this 3x squared. There's no x over here, so this goes to 0. Then we have minus 3y, okay, and then you divide that by y, okay. So we have from here, y is not here, so this goes to 0. We have 3y squared, and then we have minus 3x. So from here you can just simply write this as x squared minus y, okay, because we factorize 3 out, okay, and we have what? Y squared minus x. So this will be your final answer. And now let's look at the last problem, okay. The last problem deals with what? Multiple derivatives, okay. So let's say you come across multiple derivatives. Okay, so let's say you come across a multiple derivatives, okay, you have to take the derivatives maybe 4 times, 3 times, and all that. So let's say you have y equals what? S exponent 4, and then you have what? E exponent x, okay, and then you have to take this what? 3 times or 4 times, let's say 4 times. Pay close attention to this problem because it's the last problem and then the most confusing one, okay. You are trying to differentiate this 4 times, okay. So in order to do this, you need to use product through partial derivatives and all that, okay. There's no need to do that. Once you know what Pascal's triangle, okay, in case you've forgotten Pascal's triangle, that is what you use in what? Binomial expansion, okay. So we have what? 1 here, 1 here, 1 there, and then you just keep this. So we have 1 plus 0 will give you 1, 1 plus 1 will give us 2, 1 plus 0 will give us 1, okay, and then you continue like that. So 1 plus 0 will give you 1, 1 plus 2 will give you 3, 2 plus 1 will give you 3, then 1 plus 0 will give you 1, okay, and then proceed from here. So 1 plus 0 will give you 1, 1 plus 3, that's 4, 3 plus 3 is that 6, 3 plus 1, that's 4, 1 plus 0 will give you 1, okay. So this is what? The Pascal's triangle, okay. This is the Pascal's triangle. Note that these are what? The coefficients, okay. These are the coefficients. The 1, 4, 1, 4, 6, 4, 1 are what? Coefficients. They are coefficients, okay. So first, all you need to do is just write out the coefficients out, okay. So we'll start from 1. So equal to 1, and then we have what? Plus 4. Pay close attention, okay. Plus 6. Plus what? 4. And now what? Plus 1, okay. Kindly pay close attention so that you don't miss out. Now, this is the general formula, okay. This is the general formula. So take a look at how we solve this problem, okay. Now, we already know that you have to use Pascal's triangle, you know, when it comes to these problems, okay. Now, and then we've come to know that for differentiating 4 times, okay, this is the Pascal triangle we'll be using, okay. The last one, that's 1, 4, 6, 4, 1. So we've written that in this format. So this makes it very, very simple to solve. So now, all you have to do is just first take x, okay. First take x, keep x exponent 4, okay. So now, this is x exponent 4, so all you have to do is just, when it comes to this portion, you differentiate this expression, okay, s exponent 4, okay. So you get what? So this is what? 4s what? Cube, okay. When you get to this point, okay, you differentiate this expression again, that's 4s cube, okay. Differentiate that again, you end up with what? 12x squared, okay. And then when you get to this point, you differentiate this expression again, that's what? 12x squared, so you end up with what? 24x. And then you differentiate this expression again, which is 24x, that will give you what? 24, okay. Now you are done with what? This expression, okay. Now we are about to also do same for this expression. So from s exponent 4, you notice that we began from what? The left hand side, but for s exponent for e exponent s, will be beginning this what? Expansion from what? The right hand side, okay. So when you differentiate, so first you need to keep this expression, okay. So we have what? E exponent x over here. Now the next step is what? Differentiate backwards. So we are differentiating from here till we get to this point, okay. So when you differentiate this expression, so just like here, after writing, okay, after writing this expression, we differentiated that over here, and then we differentiated this to get this, we differentiated this to get this, and then same applies here. So that's the same principle we'll be using over here, okay. So after writing the main expression, differentiate this expression over here. So when you differentiate e exponent x, you end up with what? E exponent x, okay. When you differentiate this expression again, you end up with what? E exponent x. When you differentiate this expression again, you end up with what? E exponent x. Same applies over here. When you differentiate that again, you end up with what? E exponent x. Now, from here you can decide to what? Expand, because there's nothing like 1x exponent 4, okay, e exponent x, okay. So All you have to do is just expanding. You will notice you end up with what? The right answer. Okay, so let's try expand. So when you expand, you end up with what? X exponent 4 e exponent x plus what? So this will give us what? Exponent 3 e plus what? So this will give us a 4 times 24, that's what? 96 e exponent x times x, or you could either write the x first, okay? And then the last one will be just this expression, okay? So 24 e exponent x, okay? So you could notice that this was simple and then straight to the point. So you could try this for other, questions, okay? That's where you are told to, take multiple derivatives, okay? That's where you use Pascal's triangle. So in our next video, we'll be treating similar tricks, okay? Calculus tricks when it comes to integration. And after that, we move on to what? Integration by part. So I'll see you in the next video. Make sure to subscribe to the channel, turn on your post notifications so that you don't miss out on future videos. Like the video. In case you have any question, just let us know in the comment section. Then we'll reply to them as soon as possible. Have a lovely day.